everyone, and welcome to the Mount Washington Observatory virtual classroom. My name is Alex Branton, and I am a weather observer and a meteorologist and an education specialist here at the Mount Washington Observatory, and I am going to be presenting on the topic of climate change on Mount Washington. So if you're familiar with this program, you know how it works. If you're new to the program, the way that this program is run is that we record a video that will be posted a week before we have a live Q&A session that you can attend via Zoom or on Facebook Live. If you register on Zoom through our website, you will have the opportunity to ask questions in real time. If you view on Facebook Live, you will have the opportunity to ask questions, but we might not get to it until after the program is over. But today we will be talking about climate change on Mount Washington. If you viewed the last video that was uploaded by me on climate zones in North America, you might remember the difference between climate and weather. The difference between climate and weather is that weather is what you get, climate is what you expect. Climate is what you observe over at least a 30-year data set. And this makes Mount Washington Observatory a really unique, great opportunity for climate research. And that is because we have been doing observations since 1932 every hour. So that gives us 90 years of data, 90 years of weather observations that are human verified throughout the period. And that makes Mount Washington, again, a really unique place to do some climate research because we have been taking observations for so long. So you have that big, long data set that you can look over and see kind of how the climate is changing, what kind of variables are changing with the climate. So based off of some climate research that has been done over the past few years at the Mount Washington Observatory or for the Mount Washington Observatory is shown in this graph right here. So basically, we are seeing a slow and steady warming trend here at the summit of Mount Washington. One thing that I'd like to point out, though, is notice all the ups and downs on the graph. There's ups and downs throughout the whole graph, but there's a trend line put in the middle, meaning we have seen that slow and steady increase, even though there might be some years where it's increasing more, some years where it's increasing less, or maybe some years where it's even decreasing, where the temperatures are increasing, decreasing. But over 30 years, we have noticed that the trend is our temperatures are warming here at the summit of Mount Washington. So if we compare this with some lower elevations, this graph is showing the trend from Pinkham Notch and the summit of Mount Washington. Pinkham Notch is located just at the base of Mount Washington, and they have been doing some climate research as well. But when we compare the rate of warming between these two stations, we see that there's a slight difference between them. And we notice that Pinkham Notch is warming at a slightly faster rate than the summit of Mount Washington, and the summit of Mount Washington is warming at a slightly slower rate than the lower elevations around us. And it might be kind of difficult to see in this graph behind me because it is a slight difference, but if we look at it based on the numbers, it's a little bit easier to see. So here on Mount Washington, if we look at decades, meaning 10 years, from 1935 to 2018, we have noticed that every 10 years, Mount Washington has warmed 0.18 degrees Fahrenheit. And if we compare that with Pinkham Notch, we see that Pinkham Notch warmed at 0.25 degrees Fahrenheit per decade. So a little bit faster than the summit of Mount Washington. The entire state of New Hampshire was warming at 0.31 degrees Fahrenheit per decade. The Northeast, 0.20 degrees Fahrenheit. And the rest of the United States, 0.21 degrees Fahrenheit. So when we compare these, we see again that the summit of Mount Washington is warming at a slightly slower rate, but still warming nevertheless. So if we look at climate change based on a seasonal breakdown, we see that each season is warming, but some winter and spring in both Mount Washington and the lower elevations, especially Pinkham Notch, they're warming the fastest. So that transition between winter and spring is getting a lot faster. And we're seeing the greatest rate of warming between winter and spring at both elevations, at both stations. So why isn't the summit of Mount Washington changing as quickly as the lower elevations? And there's two theories that are kind of being studied right now, and that is the reality of us being in the clouds for most of the year. So just like this picture is showing, sometimes clouds can form just at the summit of mountains, and at Mount Washington that happens quite often. So we are in the cloud for a lot of the time, and that is kind of having an effect on our climate, on our rate of warming. We also have varying exposure to the boundary layer versus the free atmosphere. And if you're not familiar with what the boundary layer is, it is the layer where the surface influences temperature, moisture, and wind. And this layer is influenced by the Earth because the Earth will warm at a faster rate during the day when the sun is out than the air around it. And it also cools at a faster rate during the nighttime than the air around it. So that's how it affects temperature in this planetary boundary layer. Moisture, the surface of the Earth, you get a lot of evapotranspiration, which is a really big word, but all it means is water coming from soils and plants into the atmosphere, and that affects the moisture content in the planetary boundary layer. When you are at the surface of the Earth, you have lots of trees, buildings, things like that that slow down your wind. But up here on Mount Washington, we're not influenced by the planetary boundary layer as much. It's located approximately at 0.6 miles high in the atmosphere, and Mount Washington is at 6,288 feet, so just over a mile high. So we are in the planetary boundary layer about 50% of the year. The width of this layer changes based on weather systems coming through and the amount of sunlight reaching the surface. So about 50% of the year, Mount Washington is in that planetary boundary layer where we are affected by the Earth's surface. But for the other 50% of the year, we are in what we call the free atmosphere. So we're not so much affected by the surface of the Earth in this layer. So let's talk a little bit about some of the observed changes on Mount Washington that we've noticed in doing climate research. So we noticed that we've had some changes to alpine plants. We've had more frequent winter thaw events, faster snow meltouts, and greater intensity of large precipitation events. So let's talk a little bit more about these things. So alpine plants, we haven't really noticed a change in tree line since we started doing climate research up here on Mount Washington. And that's because the weather up here is still so extreme, it's so harsh that trees still can't grow. So the tree line, we haven't noticed any shifts, but we have noticed changes in flowering and fruiting times of alpine plants. So if you were to come up to the summit of Mount Washington in the summertime or in the springtime, you notice some pretty flowers on the ground, and we noticed that these flowering and fruiting times are 1 to 2 days earlier since 1935. And we've noticed that flowering and fruiting times of plants down closer to the surface are several weeks earlier than they were back before we started doing climate research. So winter thaw events, these are events in the wintertime when our snow melts off, where snow depth decreases by a lot. And this is, you can see this in the images over here. On Thursday, we have lots of snow on the ground, a pretty good snow depth. Friday, not as much snow. Sunday, much less snow on the ground. So these are what winter thaw events are, and they are becoming more frequent and more intense. Snow melt out. So that's whenever our snow melts off for the spring. So like I said earlier, our winter and our spring seasons are warming the fastest. So that means our snow is melting off faster and earlier. So our winter season, again, is warming faster. Pink of Notch, so remember how I mentioned that the lower elevations are warming a little bit faster. So Pink of Notch's snow melt is earlier by about 2 weeks in the winter time. The southern snow season is also decreasing in length. So there's still climate research ongoing. Earth's climate is made up of many dynamic systems that all interact in very complicated ways. So climate research is constantly being conducted, and it changes with every new data set. So every 10 years or so, we get a new climate data set so we can adjust our climate research and do more to see what's happening with Earth's atmosphere. And if you want to contribute to this research, it's really easy for you to do at home or in the classroom through COCO-ROS. This stands for Community Rain, Hail, and Snow Observation. So if you want to participate in this program, you can visit their website and you can start collecting your own rain, snow, and hail. And climate researchers use this data so they can conduct research on precipitation rates and amounts and types for all these stations across the United States and even across the world. So if you would like to get involved in this program, please visit COCO-ROS's website and you can start contributing to the climate research throughout the United States. So let's kind of summarize what we talked about here, some big takeaways from this presentation. So we did talk about how Mount Washington's climate is changing, but it is changing at a slower rate than the lower elevations. And this could be due to boundary layer exposure and our length of time spent in the clouds. We have noticed impacts on alpine plants and the snow season, And there's always going to be more research being done, and we need more research being done. And if you would like to contribute to that research, you can join COPA-RES and start collecting your own precipitation data. So that's all I have for the climate change on Mount Washington presentation. If you would like to join me for the live Q&A session, you can do so by visiting mountwashington.org/classroom and registering for the Zoom session, or you can join us via Facebook Live. And we would like to encourage you to submit questions ahead of time. That way we can answer your questions more thoroughly in that live Q&A session, but we will still take your questions in real time as well. So submit those questions and registering through Zoom, or you can email education@mountwashington.org. So I hope to see you in our live Q&A session, and that's all I have for this presentation.